Observing physical patterns to gain ideas for technological patterns. Environmental Program 2024-2025, First Junior High School of Oropos, Assistant Professors Theodosiou Theodoros, Zeaki Marilena.
The role of observation. From the first steps of man on Earth, the observation of nature has played a major role in the development of technological ideas. The more we study nature, the wiser we become, because nature has found ways to deal with difficult problems related to survival. This whole process is called biomimicry.
What is biomimic? Biomimetics or biomimicry is the evolution of the models, systems, and elements of nature for the purpose of solving complex human problems. Nature has solved engineering problems such as self-healing abilities, environmental exposure tolerance and resistance, self-assembly, and harness solar energy, etc. Etymology of the word. The term biomimetics comes from the ancient Greek bios, meaning life, and the word mimesis, emulation.
Evolution of nature. Nature has been evolving for about 3.8 billion years since life is estimated to have appeared on Earth. Biological materials are highly organized from the molecular to the macro scale, often in hierarchical manner, with complex nanoarchitecture, ultimately composing a myriad of different functional elements. History of biomimics. One of the earliest examples of biomimicry was the study of birds to enable human flight. Although he never succeeded in creating a flying machine, Leonardo da Vinci was a keen observer of bird anatomy and flight, and made many notes and sketches of his observations as well as sketches of flying machines. The Wright brothers, who succeeded in flying the first heavier-than-air aircraft in 1903, are said to have drawn inspiration from observations of pigeons in flight. Bio-inspired technologies. Biomimetics can find application in many areas of human activity. This is because the diversity and complexity of biological models that can be copied is very large. Biomimetic applications that have commercial use are found today in many fields of human activity.
Biomimics in tool design. Nature through evolution uses many tools. People through observation get from these tools the basic idea to design tools for human use.
Soft grip tool. Researchers at King's College London investigated how they could copy the octopus's suction cups. By copying the biological model of the suction cup, they created a 3D printed elastic mouthpiece that has microsuction cups for attention without disturbing the user. Biomimic robots. These robots have a variety of forms imitating the shape and movement of animals. The air penguins can fly autonomously and in groups, avoiding collisions with obstacles and each other. Their movement is inspired by the underwater swimming of penguins. Wind turbine inspired by nature. The albatross, an impressive bird for its abilities, is a field of research for scientists who aim to design wings for more efficient and quieter wind turbines. So by studying the wings of the impressive albatross, they copied their shape and managed to make the wind turbines work at a lower wind speed, thus increasing their energy efficiency.
A Westchester University professor has discovered new wings for wind turbines by copying the fins of a whale, which are unique in nature.
Biomimics in the exploitation of solar energy. Every year, solar panel companies spend billions on research looking for better distribution in space or rotation. And to this problem, nature has found the ultimate solution through billions of years of evolution. So the solution, researchers believe, lies in the sunflower and how it exploits solar energy for better performance. Nature-inspired sports swimwear. Professor George Lauder found that the surface of shark skin helps reduce drag and increase thrust as the animal swims. Interestingly, after research, a company manufactured high-tech one-piece swimsuits that mimic shark skin. They were used for several years by world-class athletes until their use was discontinued. Strong fixation inspired by nature. Velcro was inspired by plant seeds that had become hooked on the clothes of an engineer and his dog. As an engineer and interpreter, Mr. Mashrou examined the seed under a microscope and realized that the tiny hooks on the seed allowed it to stick exceptionally well to loosely woven fabrics and animal fur. This sparked his idea to mimic the external shape of the seed to create a Velcro fastening system. Evolving transportation with nature as a guide. As transportation evolves, emphasis on biomimetic design is increasing. It offers many benefits to vehicles by improving their shape, structure, aerodynamics, and performance. All of this can help reduce fuel consumption and emissions and protect the environment. Biomimicry in transportation. Aircraft wing designs and flight techniques are inspired by birds and bats. The aerodynamics of Japan's Shinkansen high-speed train were modeled after the beak of the kingfisher's bird to save energy. Architectural ideas from nature. Sustainability in the built environment has never been more relevant. But did you know that architects are increasingly turning to the natural world for inspiration as they strive to design environmentally friendly buildings? For example, if we look back centuries, we will find that Filippo Brunelleschi studied eggshells to create a thinner and lighter dome for his cathedral in Florence.
Eastgate Center. In Zimbabwe, the commercial building was designed by architect Mick Pierce, and it mimics the self-cooling mounds built by termites in Africa. These termites ensure constant temperatures inside their nests despite extreme outside temperatures.
Shanghai Natural Museum. Architects designed the structure of this museum, which expresses architectural themes found in nature. A grey roof rises from the site plan, spiraling logarithmically like the shell of a nautilus. 100 per atrium rises within that organizing geometry, transmitting natural light through a craggy lattice that mimics the shape and organization of living cells.
Biomorphic architecture. Biomorphic architecture refers to the use of morphological and geometric elements found in nature as a source of inspiration for aesthetic qualities in designed architecture. A historical example of biomorphic architecture dates back to the Egyptian, Greek, and Roman civilizations who used tree and plant forms in the decoration of structural columns.
Biomorphic buildings. Here we see some well-known buildings with biomorphic architecture, such as the Beijing Olympic Stadium, which looks like a nest and is therefore called the Nest, or the Burj Khalifa in Dubai, whose base represents the seed of a plant.
Metamaterials inspired by the geometry of the cell. When we look at cellular structures, it's easy to see why small is beautiful. Metavoxel recreates lightweight and strong cellular geometries to produce metamaterials that can improve structural performance and reduce the cost and environmental footprint of the built environment. Low-density, high-performance cellular materials such as bone, bamboo, and sea sponges are nature's way of doing more with less, delivering structural performance and multifunctionality at all scales. Incorporating enzymes for better plastic degradation, entropic materials. I think we can all agree none of us want plastic waste in our landfills and, even worse, in our oceans. Solving the problem at the source is the first prize for our plastic crisis, although some plastics are extremely useful. Entropic materials is solving the plastic waste problem from the inside out by incorporating enzymes directly into certain plastics to accelerate natural degradation. These plastics break down at the end of their life into biodegradable or chemically recyclable small molecules without producing microplastics in accessible and life-friendly conditions, such as hot baths or composting. Biomedical applications with nature as a guide. Millions of years of natural evolution have endowed biological systems with a remarkable ability to adapt to complex environmental changes. As a scientific field, bionics allows researchers to combine biological principles with engineering and integrate knowledge from different disciplines to create more efficient, sustainable, and intelligent biomedical tools and technologies. The result is improved quality of healthcare. Sun protection cream inspired by the eye. Sunscreen is often seen as our savior from the sun, but the use of toxic chemicals has many unintended consequences for our ocean's sensitive organisms, like coral. A company has created a new sunscreen inspired by compounds that naturally accumulate in the lens of the human eye to absorb UVA and UVB radiation. By isolating and stabilizing this molecule, they are able to create a safe, environmentally friendly sunscreen. Biomimics in dental applications. Biomimetic dentistry is a therapeutic approach that seeks to preserve tooth structure and restore the function and aesthetics of natural teeth by applying natural models. Biomimetic dentistry is commonly applied in restorative and cosmetic dentistry. Microneedles, an idea taken from mosquitoes. Microneedles, inspired by the structure and piercing mechanism of mosquito proboscises, offer a promising avenue for painless drug delivery and other medical applications. Scientists are studying how mosquitoes can be fed painlessly, particularly their use of a flexible serrated needle-like structure and numbing agents. The goal is to create microneedles that mimic these features for minimal pain and efficient drug absorption.
Biomimic armor. Nature has a wide range of biological protection strategies that demonstrate resilience to impact stress. These strategies also serve a certain degree of flexibility that contributes to a comfortable body movement. Consequently, researchers have developed biomimetic mechanical structures that mimic natural strategies to protect primarily humans. Conclusions. The observation and study of nature can provide solutions to problems faced by modern man, even in the current field of artificial intelligence. Therefore, we should all take care of its protection, because in the way we protect ourselves and future generations.